14.4 differentials part 2. We're going to talk about linearization. Here's a formula. L of xy is f of x0, y0 plus fx, x minus x0, fy, y minus y0. This circled part here is just a fancy name for df. So we're going to build a function which is going to be a starting value plus a change, which can give us a new value at x and y as a function of x and y. This linearization, you can take a curvy surface and then you linearize it by slapping a tangent plane on the curvy surface. There's a reason for this that we'll talk about later. We're going to start with this function, x squared plus y squared. Let's find the linearization at 1, 2, f of 1, 2. In this case, 1 is x0 and 2 is y0. So in case you're wondering, we're going to find three coefficients, this, and this. First of all, f of 1, 2 is 1 squared plus 2 squared, or 5. So we're going to put a 5 right there. And then we're going to calculate fx is 2x. We take the partial derivative. Fx at 1, 2 is 2 times 1, or 2. And so that 2 is going to go right there. Fy is 2y. That's just a simple partial derivative here. And let's get rid of this picture here. Fy at 1, 2 is 2 times 2, or 4. So we're going to put a 4 right here. And of course, x0, y0 was 1, 2. Those are the starting point. We're going to put a 1 right here and a 2 right here. And we have our linearization. So we have L of x, y is 5 plus 2 times x minus 1 plus 4 times y minus 2. And we can simplify that. L of xy is equal to 2x plus 4y. And we have minus 2 minus 8 is negative 10 plus 5 minus 5. Now before we wanted to find out what happened if we started out here and we changed x by 0.1 and y by 0.2. Let's calculate L of 1.1, 2.2. We get 2 times 1.1 plus 4 times 2.2 minus 5. That's 2.2 plus 8.8 minus 5. That's 11 minus 5, or 6. You see what happened? F changed by 1. It's the exact same concept. We're just building a function rather than calculating one result. That's called a linearization. And here we do fairly simple problems, but in the broader context, sometimes the linearization is all we have. There's many times in physical science we know these rates of change based on certain physical parameters. If you know a force, you know the acceleration, you can calculate a change in velocity. And so sometimes you can use this linearization to reconstruct the function. Okay, we have a function value here. Now we have a new function value here. And you can kind of walk your way through the surface to predict what the function looks like. And so that's the end game. This provides a numerical solution to a differential equation. So Calculus 3, we walk through some simple problems just to get used to all these concepts. Okay, that's the end of part 2. We'll be back with part 3 shortly.